Great, thank you. Okay, hi everyone. My name is Mark Baumgartner. I'm from the Woods Hole Oceanographic Institution, and I'll be moderating this session. I'm also the first speaker. So can we have the slides? Great. Geolocation marking is the session. Next. Oh, I have control. Sorry. So, great. Michael just gave you a history of how the Ropeless Consortium came about, and Michelle referred to this as well. This is a quote from a 2010 concept paper that NIMS did after that Gulf Great South Channel agreement from the USTRT to open that to ropeless fishing, at least on a trial basis. And NIMS came up with reasons why they were concerned about that. And this is a slide that I presented at the 2018 workshop, which predated the first Ropeless Consortium meeting by several months. And I'm just going to read it out loud because I think this is really important and sort of guides what we're doing with gear location marking. So problems with gear conflict are the main reason why buoy lineless fishing, aka ropeless fishing, aka on-demand fishing, are not being conducted on a broad-scale basis. Any unmarked fixed gear would be susceptible to being towed through by mobile gear and set over by other fixed gear and vice versa. Therefore, in order to encourage buoy lineless fishing operations, gear conflicts would need to be addressed. So there's been tremendous progress in ropeless fishing, particularly with advancing gear retrieval, getting gear from the seafloor to the sea surface. But there's been less progress. This is freaking me out because it's a little slower online. Sorry. There's been less progress in addressing gear conflict using gear location marking. But less progress doesn't mean no progress. There's been actually some very good progress. And that includes the sharing of surface GPS marked gear locations through cloud portals like EarthRange or RMW Hub. For underwater acoustic localization, we have these community acoustic localization systems like EdgeTech's proprietary Capri or Fontus's open source implementation. We have directional ranging systems like what Teledyne and Ropeless systems are offering. And then Fontus envisions doing a lot of this gear location marking with open standards. So this has been tremendous progress, I think. So just to remind everyone, gear localization, what we're going to be talking about, a number of the talks in this session we'll be talking about, is not the same thing as gear location marking. And so gear localization is done in three different flavors. The first is surface GPS marking, just records the location of the vessel when the gear goes overboard. And all you need to do it is a GPS. The next is ranging, which if you want to do underwater acoustic localization, this ranging just determines the position of an acoustic device attached to gear on the seafloor. You need a GPS, you need a transducer, and you need an acoustic device on the gear. And then finally, there's directional ranging, which does sort of the same thing as ranging in that you're trying to localize the gear on the seafloor, but it does it with a ship-mounted transducer and a directional acoustic receiver, which gives you a bearing to the gear. So as I said, and if you want to know more about acoustic localization for on-demand, I did a webinar about a year ago, and I encourage you to view it. It's about 45 minutes long, but it'll get you up to speed on the basics of sort of ranging and directional ranging, if you wish. You can find it on the Ropeless website. Okay, once again, gear localization is not the same as gear location marking. Gear localization is trying to figure out where the gear is on the seafloor to estimate that position. And we're going to hear a number of talks sort of assessing how to do that and how well we're doing at it. Gear location marking is more sort of the ecosystem around that localizations, so that we're able to find out where the gear is in a way that doesn't impact fishing operations, and then make that localization information available to other fishers and enforcement for two and only two purposes: to avoid gear conflict and allow enforcement to locate and inspect gear. Okay, so where do we need to go with this? So I think gear location marking and gear localization is something that's relatively new, even though we've been talking about it since 2018. It's relatively new to everyone. And so I think there needs to be a period of assessment where we try just figure out, how does this actually work? How accurate can these systems be? And what are the pros and cons? What are the uh, what's good and what's not about these approaches? And then I think it's extremely important for regulators to articulate what it is they need from a gear location marking system in their jurisdictions for their fisheries. I was involved with a group, Louis Baumwell, Elizabeth Vesnia, and Sean Brilliant, to try to come up with, to ask a bunch of stakeholders, what is it that you want out of a gear location marking system? And basically just write down what we heard from them. And that's a report that I think that regulators could turn to say, well, what do we need for my fishery? Do we need what was in that report, or do we need something else? So it's a good starting place. And then finally, I think it's quite important for us to be having standards for communicating gear location information. Okay. So we've got a great slate of talks. I'm really excited about this session. We've got Hannah and Emily, and Eric is not here because he's a federal employee and not allowed to be here, but we have his presentation, and David and Aaron. So the first talk happens to be mine. And so now I'm going to start timing myself so I don't overindulge. There we go. Okay, and just skip right over. So I'm going to talk about standardizing methods to evaluate the accuracy of localizing on-demand gear. So as you'll see in this session, there are a number of groups that are looking to assess the accuracy of different commercial gear localization systems. Each group shares similar goals, even though they're sort of spread out all the way from Canada to the US. And so I thought standardizing assessment methods amongst these groups would be really important. Assessing accuracy, for God's sakes, assessing accuracy across these groups, or standardizing the methodology across these groups, would also allow us to compare their results from different environments. So accuracy is going to vary by water depth, currents, acoustic conditions, environmental conditions, and it'd be great if everyone was doing the same thing so that we could compare results directly. Okay, so this methodology is pretty simple. You put some gear on the seafloor that you want to localize. The first thing you want to do is figure out, where is that gear? So you'd say, well, let's just use a GPS, but a GPS doesn't work on the seafloor. Radio waves don't penetrate salt water. And so we can't just use a GPS to figure out where the gear actually is on the surface of the planet. We have to use this other methodology. And so you would deploy the gear and do what we call a survey, which I'll describe in just a second. And then whatever system you actually want to evaluate, you would compare to that surveyed location. So you want to deploy the on-demand gear with at least one system that can provide slant range or acoustic travel time. There we go. And then you want to conduct a survey simply by circling the deployed gear, stopping periodically to collect a slant range and travel time, as well as the GPS position of the transducer. The survey is going to provide you the best possible estimate of where that gear is on the seafloor. And so when you want to go to evaluate some system, you would do this survey, you would figure out where the gear actually is, collect localization information from the system that you actually want to evaluate, and then compare those localizations back to the surveyed position. Real simple. So here it is in graphical form. Here's a dot. That's the on-demand gear to be localized. You deploy it. You're not quite sure where it is on the seafloor. You collect the water depth at that location. You back your ship off 100, 200, 300 meters, whatever. And you stop and you collect a slant range or travel time estimate at that position and the GPS position of the transducer. You take those simultaneously. And then you do it, you move the ship, you do it again. You do it again, you do it again and again and again in a circle, so you have nice geometry. If you watch the webinar, you'll know what geometry is. At each one of those survey locations, you can calculate the range from the survey position to the gear, because we know from Pythagoras that the range is equal to the square root of the slant range squared minus the depth squared, two things that we've actually measured. So we know that the gear is somewhere on this circle, but we don't know where. So we can go plot those range circles for all of our survey positions, and you'll notice that all of those range circles converge on one location. That's actually the location where our gear is. That's our best estimate of the position of the gear. Okay, we don't do this in practice using graph paper and circles. We use nonlinear least squares regression. It's a relatively simple procedure. It's been around forever, as has this survey methodology been around forever. I'm happy to explain it to you, but I don't have time now. Once you go through this procedure, now you know where the gear is. And now you can start taking other measurements with the system that you actually want to evaluate and compare to this surveyed position. So this is your ground truth that you've just produced. Okay. So, oh, crikey. That's where the meeting's done. Let's go to the bar. Can I have my slides back? Oh, close. All right, I'll take it from here. Maybe. Yeah, that was dramatic. Awesome. Okay. So now you go with the system that you actually want to evaluate. Maybe it's a system that's directional ranging. Maybe it's a system that does ranging. Maybe it's the GPS position, the surface GPS position of where you drop something, drop the gear. You collect all those positions, but now you have something to compare it back to. And there you go. So now we can, for every localization, we have a distance to the actual position of the gear, the surveyed position. You can come up with a bar graph or however you want to display it of the positional accuracy of this system. You can even attach another system to this and do the exact same thing and compare between systems. As long as you have that surveyed location, you're good. Okay. So because these groups were all doing this, I wrote some software for them all to use to do all these calculations. So it's pretty simple. You just fill out this like text file. At the top has your survey information. At the bottom has all the positions that you want to compare to your surveyed location. There's a program that you just reads that input file. You hit go and it spits out a whole bunch of stuff, including the surveyed latitude and longitude determined by nonlinear least squares regression. And then it has another couple of another couple of diagnostic plots to plot range circles. You can sort of assess graphically how good is this position estimate. And then you can, has a bunch of plots that sort of help you understand the comparison of the localization information to the surveyed data so that you can actually assess positional accuracy. And I've given the software to all the folks, and hopefully some of them are using it. I know Northeast Fisheries Science Center is. So that's all I got. So thank you.